Hello, and this is Joe at VaultSync Solutions. I wanted to show you today that, well, in the physics domain, these shouldn't be able to run in a browser. So our claim is that I'm going to run general relativistic magnetohydrodynamics in this browser tab with no cloud, no cluster, no GPU, just your browser and some WebAssembly. And if that sounds impossible to you, well, I'd like you to watch. Here we go. So our solution, GRMHD, Magnetohydrodynamics, we're going to choose, in this particular selection, we're going to choose GRMHD torus live against our GPU. And again, we can run that, but again, I just told you we're not going to use GPU. So we're going to do linear MRI dispersion or shock tube, one of these two. Let's go ahead and do MRI quality, Fishbone-Moncrief torus. And we're going to run this with the default settings and hit compute. And as you can see, within about 30 to 40 milliseconds, we're able to get a response result almost immediately with graphs that actually represent the data to which I can review, download, and explore them, as well as observational information that then I can use for whatever I might be reporting on. And I can change my references and increase it, as well as download a bundle in order to take that to whatever system that I want. What this math usually does require? Well, generally, GRMHD simulations model magnetized plasma in a curved spacetime, or an accretion disk, the neutron star mergers, jet formation, all of these things. It's a kind of computation. It really requires institutional high precision computing clusters. Hundreds of cores, days of wall clock time, six-figure infrastructure budgets. The output usually gets published in a physical review D, not in Chrome and not in a browser, for sure. So as you see, we just ran the Fishbone-Moncrief torus, and I just showed you that this standard test problem in computational astrophysics, of course, what am I running it on? Well, as you can see, these pieces of information are already telling you exactly what we're running it against. 192 squared resolution on a cluster is a routine job in a browser. This should not work at all. That's something you need to know. Yet it is. Within 3 seconds, we have 46,312 integration steps and a validated output. Again, this is not possible. And below, we can see the validation metrics actually derive directly from this run. And it isn't that it just does computations. It's validating them against a published referenceable standard. And this run conforms to those 43 reference standards across 9 domains. The engine is authority on correctness, precision, and reproducibility, not on the physics itself. We conform to their standards. We're not defining them. So you can actually expand to what those are, and you can link to them and review them should you wish to. Well, let's go ahead and take a look at LIGO chirp mass. So in this case, as you can see, we could go directly there, or we could go to LIGO itself and run an analyzer. Now, of course, this is a module, but I want you to see that we can do this directly inside of a browser, and we can show graphs, related charts, and information associated with that. And in this, we are doing a sample rate of 4096 hertz at 32 segments, 64 templates, SNR resolution of 8 and 200 PE samples. And of course, we could change our detector all the way up to Virgo, and we could do quite a few more, right? Or we can go into BSSN and configure it, and then bring it back here. As you see, we've identified a way and a methodology that aligns to validated bindings against validated metrics. And again, we are telling you where we are with it and whether or not it's precise and whether or not it works. And we measure against a reference. Some of these tools we provide at a minimal cost. The most in many of these situations is every tool that we have is under $40 a month. So I want to give you some basic numbers. We have around 33 computational engines, 130 plus validated modules, 14 domain applications spanning plasma physics to quantum circuits and cosmology. 95% of those computations finish in around 100 milliseconds. This is specifically on the HPC tier. That's our highest. The full engine suite is around $40 a month. There's no seat minimums, no enterprise sales calls, no waiting for a cluster time. If you're a researcher, a student, or anyone needs this math and you can't justify the infrastructure cost, well, this exists today. And it gives you as much as we can give you running directly in your browser at $40 a month. And right now we're doing a 14-day free trial. You come in, you test these out. If you like what you see, you continue, and you can run anything for those 14 days. And after the 14 days, we're not going to prevent you from accessing. In fact, we give you our standard library, which still gives you quite a bit of functionality and features. From geophysics, fluids, quantum energy, materials, and topology, and you get access to all of our plugins built for standard. And while they may not be specifically general relativity, magnetohydrodynamics, they do everything else. And that is the value proposition we're presenting to you. Thank you. Again, gdbs.getvaultsync.com. My name is Joe Garrett. I'm here to help you. And if you ever need an additional feature, go to your user menu at the top right of GDBS, click Help and Support, and do a feature request. Takes a few minutes, you submit it, and we'll try to help you. Have a good one.